Hey guys, so today I'm going to show off MeshQL 2 and show off some of the improvements, performance gains, and yeah, features that were added. So the first thing is that there's just a little bit of refactoring, and a lot of this was to be able to add different mesh backends later. You'll have to see, but we're working on some stuff in that domain. And then let's kind of go through some of the other things. So I think we can just kind of get into an example here. Um, so right now, let's go off of this turbo machiner example. So let's first off just kind of load this without any of this code and kind of step by step through it all and then kind of see what we get. So so first thing is we're loading this step file, which it'll automatically download it if you just run this cell here. And then let's just use the show command if we as we've done in the past. And that should load everything exactly the same. Let me comment this out as well. So if we load this show, yeah, so essentially this was generated from another package of ours that we're about to release. But the idea is that it generates this turbo machinery blade um, setup where essentially it takes in the blade and it sets up kind of an inlet outlet structure. This is for a rotor blade. And uh, so a few things that we've added is we have completely abstracted the preprocessor. So essentially the way this works is you can now yourself as the user define your own preprocessor. So right now we're using our split preprocessor that we have in the past. But if you have a class that essentially obeys this preprocessor abstract class, then you can essentially use it and do your own operations. And the only thing it has to have is this apply function. And the apply function will essentially be able to take in initial geometry, do some sort of pre-processing stage on it, and then shoot that out into a geometry that can be used and meshed, right? So yeah, so with this split thing, we have an apply operation that essentially takes it and applies all the splits right here, right? So it gets all our split faces and it goes ahead and splits. And then I'll get to the caching stuff later. So going back, so yeah, so the first thing we have here is we have this preprocessor, right? So the first thing is you have our split, and let's go ahead and just kind of show preprocessor by preprocessor. So let's do each split plane. Let's just go ahead and show this. This is nothing new. This is just taking the old stuff we had in the past, and essentially it's the same thing we had before, right? We're essentially just slicing the using the from plane slice plane and splitting it that way. Then the same thing here. So this is just going to put both of these split planes, and as you can see, now we have two split planes, right? So the first thing you may notice here is we manually defined the apply right now. So before we would, if you just did dot group, it would kind of automatically apply it. But then we realized there's a lot of things in groups that you don't need to necessarily apply. And to kind of save on performance, we have it so the user manually applies. And that way you can kind of, for a lot of these operations that don't need to go through a whole split apply operation, you can kind of group all of these split planes into one giant split at the end and then apply all at once. So this is just performance improvement. So then we added this new thing called a group, right? I don't believe we had this on V1, but a group is essentially we can go ahead and we can apply the first splits, and then we now take the initial split plane from here and pass it into the group, and then we can apply specific splits onto that group. So this is a new split operation from ratios. So what exactly does that do? So let's go ahead and turn snap off, and we can kind of go from there, right? So we'll go ahead and do false, and let's do a show here. And if and let's just kind of start with 1, right? So instead of 0.95, we're just going to start with 0.45. And as you can see here, the way front ratios work is kind of interesting. So the way it works is from ratios will, so if you go here, and let me turn this upper show off so it doesn't take up space. So what we did here is we have a start select and we have an end select, right? And the way this works is you want to essentially define a wire that this thing can use to kind of go around that wire and apply splits. And so what I mean by that is, in our circumstance, we want to apply. So we're trying to essentially do a transfinite kind of structured mesh, right? And if you remember from V1, in order to do structured meshes, we have to break things into things that are transfinite. So in Gmesh, for example, like this is a transfinite volume, right? It's like 4 corners, 1, 2, 3, 4, right? And that's the reason why we did these initial plane cuts to begin with, right? But this has like all kinds of like corners. You have corners here, you have corners here. We need these all to be transfinite. So ideally, what we want to do is we want to apply a split here, a split maybe here and here. So maybe we make like a transfinite volume here and a transfinite volume here. And essentially, you'll see. But the idea is we want to apply splits so that we can make everything into a transfinite volume, right? And so what we just did with from ratio is we selected the top wire, which is the top airfoil up here, and the bottom one, which is oh, where is it? Yeah, so essentially the bottom plane here. So the airfoil that's at the bottom over here. So we're selecting both of those wires. And then the ratio means like how far should we go around this wire before we find the point that we want, right? So if we look here, we told it that we wanted 0.45 for kind of the ratio around this wire to loop around, right? So this is 0.45, but notice something here. So let me go ahead and turn on transparent. So obviously we don't want to find the exact ratio to just, be able to snap to this corner over here, right? So what do? So there's a snap option. So if we turn the snap option to true and we run this, so what it just did here is it now it has gone around this wire. It is now a 0.45 ratio, and it just snapped to this corner. That's great. That's exactly what we want, right? And so the 0.95 is essentially just adding another one of these planes. So we add a 0.95, and then we run this. There we go. Now we have two split planes. One is going 0.45 ratio around here, and then it's essentially splitting and it's snapping and then splitting this plane here. And this is going along the surface of this blade here. And then here, it's doing the same thing, but put 0.95 around the wire, and it's snapping to this area here, and then it's splitting, right? And notice how this isn't actually, the split hasn't been applied yet. This is just visualizing what the split planes should look like, right? And so if you okay, so now we kind of have like a mesh here that is it's not transfinite yet. We want to make it so it's like four corners on top and bottom. And so ideally, another thing we could do is maybe we could take this leading and this trailing edge here, and maybe along its normal, we could then kind of just split there, right? So if we split there, then we would have now 1, 2, 3, 4, and then same thing here. If we split here, 1, 2, 3, 4. So let's go ahead and do that. So we added a new preprocessor also for splits called from normals, and essentially it's doing that same selection thing. It's selecting the interior edge, and then it's doing a filter. So it's doing essentially a edge filter for the edge centers, and it's saying, okay, if it's less than 0, the reason why it's less than 0 is, if we kind of look at the axis here, this is the x, which is in red. So this is the negative direction, and this is the I'm sorry, this is the positive direction. That's the negative direction. So we are applying for less than x, and we're telling it what axis to go along. So if we apply this and we show it, so there we go. So now we have this normal plane. So let's take a look. So we have this normal plane, and notice how there's two of them, right? The reason why there's two is because we defined this axis right here, right? So we want it to go along the negative x-axis and the positive y-axis, and that's exactly what it's doing here, right? So we have our negative x, positive y, right? So that's the first normal plane, and then simply we just do the same thing for the second normal plane, split plane. And so we go here. Um, uh, so here we go. We have our normal planes, and exactly we have our axes defined here. And then you don't need to do an apply because at the end it does one final apply. You can do apply if you want. But yeah, so now if we go ahead and just get to this show, which is at the end, it applies all the splits, and it just shows us the final split thing, right? And there you go. And notice how that was really fast, right? The reason why that was fast is in V2, we actually did a few things. So if we ls the temp meshql folder, we have two things here. We have breps, so let's go ahead and ls that. And this is actually caching all of these split operations so that when you apply like a ginormous split and you just want to like kind of focus on more, mesh specific stuff down here, you don't have to resplit every time. You can just load the brep of the splits. So that is cached. And then the second thing that is cached is we go here, there's this thing called regions. And let's go ahead and just like, cat one of these, right? So uh, for these like these operations here, like interior or even in the interior exterior ones in split, it is caching what faces are exterior and interior. And the way we determine that is raycasting because that is like the most accurate way we found so far to define define if a face is interior, exterior, or split, which is like essentially split that's like the faces are right next to each other. And that is the fastest, not the fastest, but actually the most accurate way to determine this. There's other ways where you can find the take the dot product of your normals. We've noticed that that has not really, um, you know, given the best accuracy for determining this. So we kind of, for now, we deal with that with caching. So it caches these region categories once, and then it loads it from the cache, right? And if you want to delete any of these cache, you could just pull up this thing called um, cache utils, I believe. I don't know, cache service, my bad. So if you do cache service dot clear cache, it'll clear everything, right? Great. So we have now defined our splits, which is great because we have now everything is transfinite volume, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And because these are B reps, these are B splines, this is actually one continuous edge here. It's not just a bunch of splits. Like if you use polyline, you're going to have a bad time. But if you use B spline, then this is all one edge. This is all one edge, obviously, because it's a line, and this is all one edge. So everything's now transfinite, which is perfect. And then we like before we set transfinite audio. We say how many max nodes we want through, which this is in the V1 video if you want to kind of go back and um, rehearse what that is. And then we define our interior and we add the boundary layer, how big we want the boundary layer to be, and then we add some labels. So these are all just labels. And if we do this final thing and we just show the mesh, then it goes through, it meshes it, and it displays it. And notice how quick that was because it cached most of the um, like really like just expensive operations. If I were to clear the cache, that would have taken like 17 seconds. So it's nice that this was just able to happen really quick, so you can just kind of really fast go through, debug, display, like get everything in the way you want it, right? That's a little bit about the stuff we've done with the preprocessor. We've made the splits even more useful, which is really helpful for stuff where we want to set up different types of structured meshes. And then we've also made the preprocessor incredibly like versatile. So if you don't want to split, you want to apply your own, you can just essentially follow this preprocessor interface, and then you can make your own preprocessor, and then just pass that type in, and then it should be type wise the same exact things you passed in. So all this like generic stuff is handled. Um, and yeah, so that's the split operations. Um,
Cool. Yeah. So the rest of it is a lot more internal. For example, we have a lot better caching and a lot of just like things that are more internal that will make a lot more sense in V3. So yeah, until then, hope you enjoyed and let us know if there's anything else that could be more useful. This was mainly making the preprocessor a lot more useful and a lot more performant in general. So keep us posted on anything else, and we will try to see if we can accommodate. So have a good day.